Alright, in this video I will be going over the test 2 review. So let's go ahead and get started. We want to remember that the square root of -1 is what we refer to as I, the imaginary unit. And so we can rewrite each of these by pulling out a square root of -1, and then in this case the only thing I can do is change the square root of -1 to I. Here we would have the square root of 64 times the square root of -1. That's going to be 8i. Here you can write this as the square root of 14 times the square root of -1. So this is negative the square root of 14i. Now on D, the only thing we have to worry about is 45 has a perfect square factor, and for that reason this radical is not considered simplified. If any of these perfect squares are a factor of 45, we have to break it down and simplify it. So notice 9 divides into 45, so it'll be the square root of 9 times the square root of 5, which is 3 square roots of 5. Now, one of the things I've told students is this little phrase, pull the I out. You could just do this. Change the sign underneath the radical to positive and just pull out an I. That's eventually what happens. We just write it as square root of -1, but that's I. So here you could write this as square root of 64 times I. That becomes 8i. All right, let's move on to number 2. So it turns out that when we're working with imaginary numbers, which is what all these are because of the i's, the algebra works very much like it does as if this were an x instead of an I. The only difference is if we get an I squared, we've got to remember I squared is equal to -1. In fact, I is the number whose square is a negative. That's what we never could have with real numbers. So here we would drop the parentheses, combine our like terms. I'm just going to go ahead and combine the like terms. We get 5 minus 6i. Just as if these were x's, we know that in this case we're going to have to distribute the negative here to each of these terms. So instead of 4 we have -4, and instead of a minus 9i we have a plus 9i. And again, you can add your like terms. 12 minus 4, that's 8, and -3 and a 9i, that's going to be plus 6i. Here we're going to FOIL, so we'll get 12 minus 8i minus 15i plus 10i squared. Now remember, I squared is -1, so really this is -10 and 12, which is 2. And these guys are I terms. We can combine them together. We get minus 23i. So remember, if you have an I squared, you have to change that to a -1. It's 10 times I squared, so 10 times -1, it just changes the sign. -10 and 12 gave us the 2. Now we got to remember on D that this is FOIL in disguise. You're going to have to multiply 2 of these. There's no shortcuts, no properties we can use to simplify this directly. So when we FOIL this, we get 4 plus 14i plus another 14i plus 49i squared. Again, the I squared is -1, so we have 4 and -49, that's -45. The 14i and another 14i is 28i. All right. On letter E, this is not considered a simplified answer because it's not in this form, a plus bi, where you have a real number and then an imaginary number. So we multiply by the conjugate of this. The conjugate is exactly the same, except same two terms, just a minus in between. And so by multiplying by the conjugate, we'll get rid of the I in the denominator, which is what we need to do. So whatever we do to the numerator, we have to do to the to the denominator, we have to do to the numerator. Now keep in mind, we're multiplying two terms times two terms. This is going to be FOIL. We're going to be foiling. So the first product, 2 times 5, we get 10. The outer product is a minus 6i. The inner product is a minus 5i. And the last product is plus 3i squared. In the denominator, remember the inner product and the outer product are going to add up to 0. That's always true. This is like when we were doing x minus 2 times x plus 2 and we were getting a difference of squares. The inner and outer products, those two terms will add up to 0. So all we really need to do is multiply the 5s. We get 25. And then the 3i's. A positive times a negative 3i, you're going to get minus 9i squared. So again, we have negative 1. That's what I squared is here. So we have a 10 and a negative 3. That's going to be 7. Minus 6i and a minus 5i is minus 11i. In the denominator, this is a negative 1. And so this becomes 25 minus negative 9, or plus 9, and we get 34. Now finally, remember, it's got to be in this form here, a plus bi. So this will be 7 over 34 minus 11 over 34 times I. All right, let's move on to number 3. Now we're solving quadratic equations, and we want to use the best method in each case. We have our choice. We could use quadratic formula for all of these first problems in number 3, but that's not necessarily the best way. Normally, we want to go, our go-to method is the factoring method. And in fact, it looks like we're going to want to use that here and here, or at least try it on C. On B, because there's no x term, I'm thinking the square root method would be your best choice. You could use factoring, but you end up solving by taking the square root of both sides anyway. And you could also use quadratic formula, but it's not going to be, the work is not going to be as easy. So here I would subtract 3x from both sides. And then we know when we factoring out a GCF is the first thing we ought to check for. Notice 3x is our GCF, or our greatest common factor here. You basically can see that 6 and 3 are both divisible by 3. That's the largest factor, or divisor. We have 2 factors of x here, and we have 1 here. They both have at least 1. You take the smaller of the 2 powers. So it'll be 3x times 2x, that's the 6x squared. And we'll need a minus 1 in here. So the basic idea, once we factor, is you have 2 numbers that multiply to 0. Well, we know that either the 3x must be 0 or the 2x minus 1. So we set each of our factors equal to 0. Here when we solve, we get 0. 3 times 0 is the only way to get 0. Or you could just divide by 3 on each side. Here we'll add 1 to both sides. We get 2x is 1. Divide by 2, we get x is 1/2. And so 0 and 1/2 are our solutions. Now we could write it as a solution set, but for me this is perfectly fine here if you want to write it that way. Letter B. Again, I don't have an x term. With the square root method, if I can get x squared equal to a number, it makes for a really nice way to solve this. So let's divide by 2. You get x squared equals negative 16. I do want to mention something here. I sometimes have students that take the square root of both sides here, and they take the square root of this side and they get 2x. But the square root of 2 is not 2, and so you can't do that. We can do this, and now let's take the square root of both sides. So let me rewrite this square root of both sides. We learned we got to do that plus or minus thing when we do that because there's going to be a positive and a negative answer. In fact, with quadratic equations, we normally find ourselves getting two answers. And the square root of negative 16 is 4i. So this will be plus or minus 4i. So your two answers are negative 4i and positive 4i, which you can write like this. Now on C, I already talked about how we're probably going to want to, well, at least try factoring this first. It's got three terms, so we're going to use the AC method. And because of the 6 here, the 6x squared, a is not 1. This one takes, there's no shortcut on this one. We're just going to have to split our b term into two terms and factor by grouping. So in this problem, AC is 6 times negative 3, or negative 18, and b is negative 7. And so let's see, 2 and 9 are the numbers that will work here. And notice they need to be opposite in sign since they multiply to a negative. And they add to a negative, so make the bigger numbers negative. Notice 2 times negative 9 is negative 18, and 2 plus negative 9 is negative 7. So we get 6x squared plus 2x minus 9x, and then bring down the minus 3. So all we've done is replaced a minus 7x with 2x minus 9x, which is equal to that. Now we can factor by grouping. We'll group the first two terms and factor out the GCF. We get 2x times 3x plus 1. Over here, we're expecting to get the same thing in the parentheses when we factor out the GCF here. So this kind of makes it a little bit easier on us. We just need to figure out what times 3x is negative 9x. Of course, that's negative 3. Notice negative 3 times this is that, and negative 3 times this is that. So that's going to work. We've got two terms with a common factor of 3x plus 1. And if you cross those factors off, you can see the other factor is going to be 2x minus 3. So now remember, we're trying to solve an equation here. We've factored the original trinomial. And so now we have a product of two numbers that equal 0. Either 3x plus 1 is 0, or 2x minus 3. So I'm just going to go ahead and solve these equations. You get 3x is negative 1, so x is negative a third. And you add 3 to both sides, you get 2x equals 3. Divide by 2, you get 3 halves. And so 3 halves and negative 1/3 are your solutions here. Now number 4, it's telling us to solve by completing the square. So what we learned is the first thing we want to do is put the x squared term and the x term on one side and everything else on the other. So we'll subtract 5 on both sides. We get negative 5 here. Now we want to complete the square. I like to do it like this. I'll just put a little square here. And whatever we do to one side, we have to do to the other. How do we figure out what to put here? Well, we're trying to complete the square at this step here. And what we're doing is creating what we call perfect square trinomial. Once we do that, we'll be able to write this as something squared. And then that'll enable us to use the square root method to finish and solve this. So the way we did this is we took half of this number, so negative 12 divide 2, and we squared that. Well, that's negative 6 squared, which is 36. That's what we need to add to create a perfect square trinomial. So we'll add 36 to the other side as well. Now we want to write this in its squared form. It's going to be x minus 6 squared. On the other side, we're going to get 31. I would just remind you that there's a nice pattern here. I mean, you could factor this using the AC method, but because it's a perfect square trinomial, we learned there's a nice pattern. Half of that number is always what will go here. If you want to convince yourself, you can multiply 2x minus 6's, and you would see that that's what that would equal. So let's go over here and finish this out. We're going to take the square root of both sides. Don't forget your plus or minus. The reason why is because we want to get to the x here, and this expression is squared, and the opposite of squaring is taking a square root. So basically, the square root cancels out the square. You're left with x minus 6. On the other side, you have plus or minus the square root of 31. So we need to still add 6 to both sides. And when we do that, we normally put the positive 6 first, in between, well, we have the plus or minus in between that and the radical. So our answer is 6 plus or minus the square root of 31, or we could write it as 6 plus the square root of 31 and 6 minus the square root of 31. Excuse me. All right, so find the zeros. Well, to find the zeros of a function, we're basically looking for values of x that you plug in as inputs and your output will be a 0. So the way to find the zeros are to set the function equal to 0. Basically setting f of x equal to 0. This is the function f of x. Now this one here I'm looking at, and it reminds me of the one we did up above where we had an x squared term and no x term. I'm going to use square root method. I'm going to go ahead and add 18 to both sides. You get 3x squared is equal to 18. Then I'm going to divide by 3. You'll get x squared equals 6. Again, I'm going to rewrite it so you can see my steps. I'll take the square root of both sides. Don't forget your plus or minus. We get x equals plus or minus the square root of 6. So again, we have two answers, the square root of 6 and negative square root of 6. Now on part B, when we set this equal to 0, we've got a little bit of a dilemma. We have negative x squared plus 3x plus 54 equals 0. We really don't want a negative in our first term. When we factor, which is what we're going to want to do here, this is a trinomial, we'd like to have a positive x squared here. So there's a really easy way to get that. We're basically just going to multiply both sides by negative 1. Now when we do that, we have to distribute here, and so every term changes signs. We get x squared minus 3x minus 54. The beauty of it all is on the other side we still have 0, don't we? Because 0 times anything is 0. And so now you'll see this is much easier to factor. We need two numbers that multiply to negative 54 and add up to negative 3. And you can play with the numbers. You'll find that 6 and 9 are the ones that work. If you didn't see it, you'd have to go through all the factors and figure out which pair works. So we need opposite signs because we multiply to a negative. Since we add to a negative, make the bigger one negative. Notice 6 times negative 9 is negative 54, and 6 plus negative 9 is negative 3. So because this is a 1x squared, I don't have to do like I did up here when I split my b term. That's because here we didn't have a 1x squared. We can just go ahead and plug in the numbers we got here. It's going to be x plus 6 and x minus 9. When we set these equal to 0, we're going to get negative 6 and 9. So those are our zeros. Now it wouldn't be too hard to plug in negative 6 here or 9. You might want to use your calculator, but you can verify that when you plug those into the function g, your output will be 0. That's why we call them zeros. All right, I'm going to go ahead and stop right here, and I'll make another video